Good afternoon, everybody. Welcome to CSSS. Today we continue our differentiation series, part 4. Today we dive on the function of function, also known as chain rule. Please, if you know that you're new to this channel, kindly like and press the notification button so as you get notified when next videos like this are posted. We post new videos regarding this course, calculus, and with the formula displayed on the board, the y dx equals the y du times du dx. So this is the general formula for chain rule. What do you accept by chain rule? Chain rule is the derivative of composite function. Chain rule is the derivative of composite function whereby a function is inside another function. So that is what chain rule is all about. For example, let's say for instance, this is a function, right? My hand, let me take my hand as a function. Well, a function inside another function. That's what we call chain rule. Yes, that's all about. With this as the general formula, we'll be using the general formula to solve through regarding this topic. Now, without wasting much time, let's solve questions regarding this topic, function of function. Now, the first question here displayed on the board is question 1: y equals bracket open 1 plus 6x bracket open raised to the power of 10. So we're going to solve this question 1, 2, 3, 4, 5 for better understanding. So I pray that just pay close attention and close look as I solve. Now, question 1 answer: y equals bracket open 1 plus 6x raised to the power of 10. Now, seeing this, we take, remember that a chain rule talk about function of another function. I told you before, I said earlier, a function inside another function. It's called chain rule. When something is together, that's chain, right? So that's what we're talking about, a function of another function. So now, we take this one now, the bracket, this 1 plus 6x as our u. So now, u equals 1 plus 6x. Now, our y equals 6, this one now is our u. We then tend to replace this one with this u here, u raised to the power of 10. I reiterate, this our bracket is our u, which is this one. While rewriting this one, y equals, instead of rewriting this one, we replace it with this one, which is u raised to the power of 10. Now, differentiate this one. Differentiate the u with respect to x. So now, finding the derivative of u with respect to x, we have 6. How come about that? Remember that in a previous video, how I told you that every constant, they are always 0. So now, this one being our constant. A constant is a number without a variable. Now, this one now is standing on its own without a variable. Variable like x, y, u, at the case may be. This one now is 0, which is out of the equation, plus 6x. Differentiating 6x will give you 6. That's how we got 6 here. Now, differentiating y with respect to u. Now, the y du equals, differentiating this one, remember I'll bring the power down, which is the 10, right? Now, the u, remove 1 from the power, which will give you 9. That is how we got this one here. Now, imputing the general formula, which says the y dx equals the y du times du dx. So with this formula now, we will solve questions, all of the questions. Now, let's continue from here. Now, remember, it is the y dx. Where's our dy du? Our dy du is this one, 10u raised to the power of 9. Now, 10u raised to the power of 9 times, where is our du dx? Our du dx is 6 multiplied by 6. So, now, dy dx equals 10u raised to the power of 9. So, we will go back to our question. What is our u? Our u is 1 plus 6x. So, we replace this one here, right? Now, 10, the u which I took from here, which is the u here, with the power of 9, times 6. Now, dy dx equals 6 times this 10. The bracket raised to the power of 9. Now, dy dx equals 6 times 10 will give you 60. The bracket open 1 plus 6x raised to the power of 9. So this is the answer for this question. This is the answer for this question. Now, question number 2. Remember, we use the same formula when dealing with fraction of function or you see rule. This is our general formula we'll be using for this problem. Now, question number 2. Y equals sine 7x. Y equals sine 7x. With the kind of question, what do you think will be our u? Yes, our u will be this. Our u will be the 7x, not the trig. Our u will be the 7x, not the trig. Now, y equals sine this u. Put it here. Remember it was here. Remember here it was 7x. Since we took this one as our u, now it will be y equals sine u. You see, that's it. Now, differentiating u with respect to x. Now, the u dx equals 7. Differentiating 7x will give you 7. Now, differentiating y with respect to u. So now, the y du will give you cos u. Remember, sine will give you cos. Y cos will give you minus sine. That is it. Now, applying the general formula, therefore, the y dx equals dy du times du dx. Right? Now, from this this question now, dy du is our cos u. Y multiplied by our du dx. Our du dx is 7. Remember that. Now, the 7 dy dx equals cos u. Yeah, what is our u here? Our u here is 7x, so replace it by 7x multiplied by 7. You see? Now, dy dx cos 7x times x. You see, this one cannot stick together. You can't stick together. So we multiply this one together. The 7 comes in front of the trig. Now, which will give us 7 cos 7x as the final answer to this question. So, diving to question 3. Now, question number 3. Y equals sine y to the power of 3. I will take our y to the power of 3 as our u. This u equals to y to the power of 3. And our y sine u of writing y to the power of 3 places with u, because since we say that let u be y to the power of 3. Now, differentiating u with respect to y. Now, du dy equals 3y to the power of 2. The differential form of this one. This one is this one. Now, the y du differentiate y with respect to u. So here now is an u. Now, the y du equals cos u. Differentiate sin u, get cos u. Want to do the reverse thing? You differentiate this one, you get minus sin u. So the differential form of this one is this one. Using the general formula, the y dx equals the y du times du dx. The y dx equals our dy du is our cos u here times our du dx, which is 3y raised to the power 2. 3y raised to the power 2. The y dx equals cos u. Remember that we took u as y raised to the power 3. Now our u here will be y raised to the power 3 times 3y raised to the power 2. Now the y du equals, you multiply this one with this one. We add them together, multiply them together. Now which will give us our final answer, which is 3y raised to the power 2 cos y raised to the power 3 as our final answer. This is our final answer for this question. Now question number 4. Question number 4. Y equals bracket open 1 plus t raised to the power 2 bracket close raised to the power of 5. Now we'll take the bracket as our u, which will give us u equals 1 plus t raised to the power 2. Now y equals u, which is this one. We say let u be this one. So now it will now give us, this one will now give us y equals u raised to the power of 5. Raised to the power of 5. Differentiating u with respect to t. See, u, t. Now the t, du dt equals, differentiating the constant, which is 1, will give us 0. Differentiating t will give us 1 plus t squared. Differentiating t squared, it will give us 2t. differentiating this one with respect to u. Now the y du equals 5u raised to the power 4. Using the general formula for chain rule, which is dy dx equals dy du times du dt. Dy dx equals, now try to substitute whatever we see dy du, we put in the value here. Now, as you can see in the board, our dy du is 5u raised to the power 4. We put it here, times our du dt. Our du dt is 1 plus 2t. So add it with this 1 plus 2t we have here. Now we multiply them together. Now, therefore, dy dx equals 5. The 5 we have here 5. Our u is our u 1 plus t plus 3 raised to the power 2. Have here. You know that this u is raised to the 4th power raised to the power 4. Now, write the 4 here. Times our du dt, which is 1 plus 2t. Have it there. Now we multiply them. The y dx equals, multiply this one with this one, will give us 5 bracket open t, 1 plus t plus t raised to the power 2 bracket close, bracket open 1 plus 2t bracket close. This is our final answer for this question. You don't open the bracket, you don't add, you don't subtract. This is our final answer. Question number 5. Y equals exponential raised to the power of 4x plus 7. U equals with power, right, the function, remember. So we take our u, 4x plus 7 as our u, while the y equals the u exponential u. So I write this one again, just substitute it using this u here. Now we differentiate this u respect to x. Now du ds equals 4. Differentiate this one, we have 4. Now differentiate this one, dy du, differentiation value of y respect to u, it give us exponential u as well. Yes, differentiating exponential u, we give you exponential u. How? Now we first, maybe to get this, to validate this one, if it is true or not, we differentiate the power, which is the u, right? Differentiating u, no, u as a variable will give us 1 times differentiate, rewrite what is differentiated, which is u, now equals 1 times this thing, used to give you exponential. So any exponential raised to the power of something will just give you the same thing, like exponential x to give you exponential x. So exponential u will definitely give you exponential u. Using the general formula, dy dx equals dy du times du dx. Now we'll move here. Dy dx equals, where is our dy du? Our dy du is exponential u, while our du dx is 4. You see? Exponential u times 4. Dy dx equals exponential. Our u here, remember our u is 4x plus 7. We write it here, 4x plus 7 times 4. Finally, dy dx equals, multiply 4 with the exponential, we give you exponential, 4 exponential raised to the power, bracket open, 4x plus 7. So this is the final answer for this question. Remember, when you see a question like this relating to chain rule, I told you before, chain rule are derivative of a composite function, whereby a function is inside another function. And as I made an illustration before, for example, this one is a function, remember, and I place this marker inside my hand, like a function inside another function. That's all this is all about. So, number 1, memorize the formula and take note of your u and the differential form of u. So if you have any question related to this one or other function, please kindly drop it at the comment section. If you have any question, you can ask. So thank you for watching.